Hey, Marshy, do you want to come say hi to stream? No, he does not want to come say hi to stream. I'm sure he'll be back to scream at me later when I'm like in the depths of trying to solve some problem. Speaking of trying to solve some problem, this morning I was like, what on earth was wrong with my solution from yesterday? It looks absolutely fine. So I just reran it and pasted the answer and it was right.
Oh my God. So you...
I solved it. I just like, I don't know, I miscopied the answer or something. I don't know. I just pasted it in again and it was like, congratulations, you got a gold star. It's like, okay, fine. So, and then like solving part 2 took me like 5 minutes or something. Right. So that's frustrating because yesterday I felt so bad. I was like, this looks fine. Like, why is my brain broken? And it was fine. It was right. It just like, I don't know.
Amazing.
So I got the stars for day 4.
I'm glad you figured it out.
Yeah. Okay, should we have a look at day 5?
Yeah. Did you put a tweet, by the way, saying
yes, I did put a tweet.
Okay, yeah. Hold on. I need to retweet that. If you want to read it, I'll read along.
Yeah, sure. Cool. Okay, hydrothermal venture. You come across a field of hydrothermal vents on the ocean floor. These vents constantly produce large, opaque clouds, so it would be best to avoid them if possible. They tend to form in lines. The submarine helpfully produces a list of nearby lines of vents. This is going to be a line intersection puzzle, isn't it? The nearby lines of vents are your puzzle input for you to review. For example, bunch O lines. Each line of vents is given as a line segment in the format x1, y1 to x2, y2, where, those are coordinates of the line segment. They include the points at both ends. Okay, so they're inclusive line segments. For now on, only consider horizontal and vertical lines. Gee, I wonder what part 2 is going to be. So the horizontal and vertical lines from the above list would produce the following diagram. Okay, yeah, this is definitely a line intersection puzzle. In this diagram, the top left corner is 0, 0, and the bottom right corner is 9, 9. Hello, Marshmallow. Each position shown is the number of lines which cover that point, or dot. No line covers the point. Top left pair of ones, for example, comes from those lines. Okay. To avoid the most dangerous area, you need to determine the number of points where at least 2 lines overlap. In the above example, this is anywhere in the diagram with a 2 or larger. All right. So this is, do you recognize this algorithm?
No, I don't. But
okay, so this is.
Like, did we have something similar like last year as well?
I don't think so, but this is this. Whoops, and don't need to save that. This is what's called a sweep line algorithm.
Huh.
I'm sure there's a specific one. So the basic idea is I'm looking at the Wikipedia entry right now. It's like you imagine a line sweeping across the plane, and you do some calculations across that plane. I'm sure there is. I've implemented this before. There's a line segment intersection. Bentley-Altman. That's it. Bentley-Altman. It's a line sweep algorithm for listing all crossings in a set of line segments. Okay, so I have implemented this algorithm before, but the thing is, I don't want to. It's actually kind of complicated. Right. So the basic idea of how it works is you, it has like a binary search tree and a priority queue and stuff. But yeah, so there's an event queue, which is a priority list of. Yes, Marshmallow. I know. Yes, you're very sweet. Basically, you keep like a priority queue of events where the events are like the beginnings of lines, and you imagine the line sweeping across. So if you hit the start of a line, then you add that to this binary search tree, the sweep line status tree, and that is the set of lines which you're currently considering. And then if you find other lines within that as you're moving the line across, then those could be intersecting. But the algorithm is actually kind of complicated. I'm probably not going to implement Bentley-Altman for this. If anyone in chat would like to implement this like properly, the proper like algorithmic computer science way, then you could implement Bentley-Altman for this.
Have you like ever used Bentley Altman for like something not which wasn't a puzzle?
I think I can't remember when I implemented it. Maybe it was at university or something. But I remember doing it because I think it was the first time I'd ever used a priority queue, which is the reason that I remember it, because I quite like priority queues. They're kind of interesting data structures. Marshmallow, what on earth are you up to? He's inside a sheet which is on a drying rack, and he's just like in full gremlin mode. Jesus.
No, Naughty and Cheshire like to do that. It's very cozy. It's like a little bag.
Yeah. Okay, so the basic idea is you could implement a line sweep algorithm like for this, which I imagine is what when the puzzle creator was inventing this, they were like, hey, people can do line sweep if they want.
Nice.
But I'm not going to do that.
Quick. Another question. When you say priority queue, you mean like a first in, first out queue?
No. A queue based on so a priority queue is a data structure which it's implemented with heaps generally. So you have a max heap, which you have some priority function which gives you the priority for a given element. Like for the Bentley Altman algorithm, you order the heap by X coordinate. So you're always considering the leftmost element. So yeah, there's probably I wonder if there's a priority queue implementation in the Rust standard library.
Because you could think of it as like having a vec of elements, and every time you add something, you run a order function on it, so that the items with the most priority are at the top. I mean, that's a terrible implementation.
That's the intuition. Yes.
Okay.
Yeah. So there's a binary heap collection in Rust, which is basically a priority queue. Yeah.
I've never used it. I've seen it. People have like thought of removing it before Rust 1.0.
Yeah. But there's a priority queue implementation in C++ as well, which I just unbuttoned my shirt. But it misses some of the operations that you might expect from a priority queue. I can't remember exactly what it's missing, but like I've implemented priority queue based algorithms before using the C++ standard library, and I think it's rekeying or something like that. But there's one operation that you might want for priority queues, which is not in the C++ one. Oh well. Anyway, that's a kind of aside, but interesting at least. Marshmallow. Okay.
I appreciate the pointer to binary heap. I would not have thought of looking at that.
Oh, key modifications not supported. Yeah.
All right.
Okay. So if we're not going to do the full-on way, hey Brain RPG, how's it going? So there's a bunch of different ways that you could implement this. You could implement it just like this diagram, where you keep a two-dimensional array of integers, and you on every line segment you iterate over all those points and you increment all of them, and then at the end you go and you check all of you count all the ones which are greater than 2, which are 2 or greater. Another way you can implement this is keeping a hash map of counts, and do very much the same thing, but instead of storing every point, you only store the points which are actually touched by a line. The way that I think I will do it is you could keep a set. You could keep a set of all points you've seen before, and because we only need to count the points where at least 2 lines overlap, then we can keep a single set of points that we have already seen. We iterate over every point for every line. You try to insert it into the set, and if it already exists in the set, you increment the global count, and then once you've seen every point, then you just print out the number of times that you tried to add something in this set, but it was already there. I think that's the entire algorithm.
Yes, that seems nice. Because like lines can also like overlap vertically. Because I was like, if you have two sets of like vertical and like horizontal lines, you could do an intersection, but not quite, unfortunately.
Yeah.
I like that.
I have a couple questions. Brain RPG is asking, any chance you could use an MD span for any of these? You could use an MD span for representing, if you were doing it, the MD span is multi-dimensional span.
Oh, okay. And a span's like a slice?
Yes.
Gotcha.
Yeah, you could use MD span if you're doing it this way, like holding a two-dimensional representation of the entire plane. Another question is, would PRing your TL ranges repo make it into the C++ standard? What do you mean? Like, will... Oh, so the TL ranges repo is stuff which I've implemented. Some of those are going to be bases for standards proposals. Maybe the Cartesian product implementation I did was a basis for a Cartesian product range, which should make it into C++ 23 because it got approved by the Library Evolution Working Group. But nice. I don't know. I don't know if I'm going to write any more standards proposals. I don't have the energy. It takes so much time and energy.
All right, shall we dive in?
Yeah, let's dive in. All right,
cool.
Gonna mute. Yeah.
Gonna mute myself. Mute. Yay. All right, we're keeping Sai right there. Can we add chat? Let's try that. Yay. Okay, so we should have chat now. All right, everyone, welcome. Sorry I was late today. Let's hide size cam. All right, cool. I changed the layout a little bit today, so hopefully like things are still like looking good. Let me know what people think of the layout. Looks fancy. Yeah, thanks. Hold on, I can make it like fancier. Maybe like this too much. It's like stroby and stuff. Yeah. Maybe I'll give people what was that, vertigo? So I figured I wouldn't like leave that on like all the time. All right. So yeah, like Sai said, I woke up late today. I apparently slept through 2 separate alarms on 2 separate devices. And then I opened my eyes because I was like, I don't know. I'm not feeling super great. Like, got a bit of a headache. I look at the clock and it's like 10:24. And we're supposed to go live at like 10:30. And we're supposed to meet up at like 10. So I was like, oh no, I'm 20 minutes late to like seeing Sai for the pre-stream. So yeah, that was fun. But I'm awake now. Sleep is good. Yeah, that's right. But sometimes you said you'd be somewhere and then you're not, and that disappoints people. And I try not to do that all too often. So we are setting ourselves up. 5 up at 1, up at 2. Let's change these to just to do that. I should have like a template in the root. I'm gonna copy this over. Parstron board. Also, hey Rusk, hey Walter, welcome to this husk of a stream. I'm trying though. Hey. Oh. 0, 0. Okay, we are copying this over. as a template. Yeah, well, they're saying the exercises got more difficult this year, and that is definitely true. I got like stuck on day 8 last year because it was like difficult and it started taking up too much time. But this year it was like day 3. Day 3 instantly like difficult. So yeah, that was annoying. All right. We have stuff. All right. So let's write our unit test again. Puzzle input. That was the remainder theorem. I don't know. It was this one? With the, what's the input here? Or was it day 2? Oh yeah, it was the binary number parsing. Oh, last year's day 8. I don't remember. I just looked like earlier this week and it was the only puzzle I had like, can I trim this? Not const? Not const. It was the only puzzle I like had 1 star in and then gave up. So yeah, bit unfortunate. What do we got here? We have our total of 5 points. So day 1 is 5. Oh yeah, last year's was the Let's Build an Interpreter. Yeah, Let's Build an Interpreter is kind of fun though. I'm not sure if was that the one? I forget. So I practiced a lot on these kinds of puzzles like this year when I was like interviewing for Microsoft. Well, not specifically for them, but just interviewing in general. But last year was the very first time I ever did puzzles like this ever. So maybe I was also just less comfortable. Oh, my mouth is dry. Yeah, I like building interpreters and stuff now and parsers. I wasn't like as comfortable last year. All right. So this puzzle, let's start by, I guess, going over lines. Each line is an input, is a set of coordinates. We'll just parse it into like coordinates and then we'll figure out how to like store it, I guess. Yeah. Okay, so for s.lines, the map, line here, and then we say dot split, line dot split, and we give it this, and then we say like that. Split equals that. Wish we could collect into a tuple. We can't yet, I believe. And then we say let's left equals split dot next dot split, and then by comma. Oh, we can do dot split once, and then we say left, right, like that, I believe. Oh, to do. Split once. Method not found. Hold on, I can't quite see my output there. Method not found in option. Oh, we need to. There, right? Unwrap. Is that an iter? Oh, no, split dot next dot unwrap. I'll split once. Let mute. GeekyDo is asking, what does pipeline pipe and an open bracket mean? So this is the way you like write closures in like Rust. So this is I don't know what other languages you know, but basically it's a way of like quickly doing inline. If we were like to write our parse function again, let parse equals s, and then to do. That's the one line variant. This is a multi-line variant, right? We can annotate it like that, but we don't need to. So in this case, here we are passing an inline function essentially. And because the type is known, we don't need to like annotate it with the type. And yeah, it works. Hopefully it answers the question. Like arrow functions in JavaScript, exactly. Very similar. Main difference like with arrow functions is oh wow. I know what that is. Yeah, you can't have them as top level functions, so you can't have them as like function exports. Okay, let's see. So we have that. I think we can like do a parse word function. S answer R answer UA comma UA. Oh, I did not mean to block got. I didn't know like what was in there. You're right. Rihanna, can you help me out? Thank you. Did not. I thought it was like, no, we were probably someone's like spamming again. Sure, let's hit that button. Let chords equals parse chord LR. And then here we say l.parse.unwrap r.parse.unwrap. Hey Josh, give us a hi on stream. Lovely. Oh, this child does not want to be held. Cat, yes. Oh, very briefly. Like, Nori's the one I can like put on my neck and she'll like sort of sit. But Chashu's like, no, don't touch me. I want lap or nothing. And usually answers nothing. She only like allows Ira to like hold her. Okay, we have chords. We can do this better. Yeah. Chord, parse chord, like that. And then we make this that. Like that. And then we do that twice. Is that right? Oh, hold on. L, R. Stir. There we go. Cat on stream. All right, I was wondering. My little cable was like jiggling, so I was like wondering if she was like eating it, but she's not, luckily. Okay, so we have our two chords. We need to figure out what we want to do with them. Split once might be useful here. We have split once. Oh, you mean like that? Split once. There. Left, right. Sure. You are right. Left. Right. That should be better, right? Split once to unwrap. Ta-da. Better. I like it. Good suggestion. Okay, parse one. Parse chord. We have our 2 chords. Chord 1, chord 2. Can we like do a range for tuple? If we say for LR in chord 1, chord 2, print line, or PBG LR? Does that work? Unfortunate. All right, so we don't have like a step for tuples quite yet. That'd be fun though. I wish we did. That'd be fun, right? So we could have like just 2 coordinates and we would like know how to like walk between them. But maybe there's like no one single solution possible there, unfortunately. All right, so right now we know that it's either like a straight line or a horizontal line, right? So one of the coordinates will be the same. We can just hard code that. Actually, we can just keep it there, I think. Hey, Josh. Let's take a look. So if we say let's rename this to C1 and C2. Input is always in increasing order. Oh, hold on. Wait, how does this work? 0.9.5.9, 8.0.0.8. Okay, let's take a look at the puzzle. 8.0.0.8. Each line of the vents is given as a line segment in form an XY, Y1, X2, Y2, IC. Oh, X1, Y1, X2, Y2. All right. So they're XY coordinate pairs. Of one end of the line segment, X2, Y2 are coordinates on the other end. These line segments include the points at both ends. 1, 1, 9, 7, 7. Yeah, exactly. Like these are like different orderings, right? So Walter's right. It is not just like any order. Unfortunately. So we actually do like need to take a look. But one of the points should be the same, I thought. For whatever reason, 8,0 and 0,8 is they're different coordinates entirely. X2, Y2. For now, only consider horizontal and vertical lines. Oh, okay, yeah. So we can skip over to 8008. All right, we just skip. That's what they want us to do. Okay, if C1.0, C2.0, for C1.1, y c1.1, c2.1 to do. Then we can like invert this. C2, 1, 0, 0. I think that's the one, right? And this becomes X. Oh. We should have a bag of coordinates somehow. Right. And this can be like an insertion of the chords. Okay. So how is it that we store the coordinates again? So we have our, essentially we want to let x2, y2. Wait, hold on. Yeah, you're right. But I can refactor it later. It's okay. Okay, let's take a look. So we want to store this in a hash set. Yes, into a set. And then we insert. And then if that point already exists, we will increment a counter. I think. Yeah. Yes. All right, let's turn this into like a proper loop. For line in s dot lines. Let mut counter equals 0. Let's verify. How many points do at least 2 lines overlap? Good. And we can't have like 3 lines overlapping because we don't have diagonals. So you can only have like a vertical. With diagonals, you can get like 3 points overlapping. So there's an interesting like phrasing that they might keep consistent, but once we add the diagonals, we like need to account for that point as well. Okay. Let mut items equals hash set new. Yeah. We need to import this. Import. Cool. Hash set becomes a hash set of U8, U8, right? Yep. Shirshak was saying like x2, y2, x1, y1, x2, y2. I think that's a good suggestion. x1 equals x2, y1, y2. y1, y2. For x in x1, x2, like that. All right. Hey, Chas. You want to come over? Oh. Oh. A cat. We have a cat. Come, cat. Snooze. Sleep. Relax. Plop. Haha. Okay. I have a cat on my lap. I'm very stuck. It's good though. Let's see if we can do any type of coding. Cat on lap, good idea. Because it's very cozy, but not good idea if you also like want to do computers. All right, let's see if we can like at least talk it through a little bit. Or if I can like, can I get cat on stream? Kind of, almost. Look, here's a tail. Yeah, the camera's like not quite positioned to be able to like look at cat.
Hey, Josh, we're done with part 1. I don't hear you, Josh. You're still muted. Oh,
Yeah, hold on. There's a cat on my lap. Yeah, we're like almost. I feel like we're super close. We're about to like insert the items into the hash set, and then that's easy going from there. It should be
nice.
But yeah.
All right. Well, we'll just move on to part 2 then.
Yes. Sounds good.
All right. Good luck.
Thank you. You too. All right, that was sight. Wait, did I mute myself? Hope I did. I don't mind going a little bit over time. We initially said we'd like time box it proper, but we're not. I'm not today. I've got some time as well. Oh, this cat has like a little crunchy. Hold on, can I show you cat? There's a little head here. Not sure if you can see. Wait, webcam only. Yes. Hi. Oh, that's better. There we go. It's me and a kitty. Oh. Little webcam view. Kitten view. Yeah. I'm getting like lots of tiny grooms. No purring though. Brief interruption for the coding stream. I need to like keep providing paths, otherwise she'll like jump off and like cause a ruckus. Whew. All right. Let's see if we can reason through this thing. So all we need to like do is insert our coordinates into the thing, and then see if coordinates already existed. And if they did, we increment the counter, and that's it. And at the end, we return the counter. So line 29 needs to become counter and stuff like to do. And then items dot push, what do we get? Y comma x1 or something like that. Yeah. Oh, we're so close. We are so close. Oh, we need an inclusive range as well. So we're doing up until, but it's like not up until, it's including. So that is a small mistake. Line 19, line 24, dot equals. All right. One-handed coding. We can do this. Okay. Okay. One bug eliminated. Next up. We say items dot insert. Whoop. Items dot insert. X1 comma Y. X comma Y1. Oh, whoa. Okay, I think someone spotted a bird. Yes, we're free. Very like panic jumping to the window. It's kind of cute. All right. Items insert. Items insert. Let's take a look. If items insert dot is some should return a if items dot insert counter plus equals 1. And then here is counter, right? Is that it? Run first test. Failed because we got out. Left 11, right 5. If not counters dot insert. Oh no, is that what? Hold on. What are we inserting? Okay, let's take a look again. I thought that would work. So we are inserting 0, 9, 1, 9, 2, 9, 3, 9, 4, 9. Is that the first coordinate? Running one test. X1, Y1. 0, 9 up until 5, 9. Second one. 8, 0, 0, 8. We skip that. 9, 4 until 3, 4. It seems we are not inserting our items correctly. Y1, Y2. Okay. Items insert. Hold on. We can do one quicker check, which is
all right, gosh, we're done with part 2 as well.
Amazing. Hey, that seemed like it was like really quick. Was it the diagonals as you thought it would be?
Yeah, exactly. Yeah.
Cool. Yeah, I feel like I'm so close. I have like one small like problem with insertion into the hash set, but otherwise we're like, this should just be working.
Cool.
Guess I'll keep cracking at it.
Yeah. Do you want to share your screen with me and we can jump on and help out?
Yeah, sure. Share screen. Okay, this is gonna. Okay, I'm sharing my screen, but you're frozen on my screen. So if people see side talking, no, you're not.
Yeah, just give me a moment. I'm just gonna clean up my solution a tiny bit as well. All right. Let's put Yasha's screen up on mine. Okay, all the folks on my stream should now be able to see Yasha's screen.
Yay. All right. So what we have here is we're inserting a coordinates. I'm just printing out because I feel like something's off. So the first coordinate 0,959, and we see like we insert 0,9 and then up until like 5,9, and that's good. But then 94,34 is we're skipping that one, and we get all the way to 7074, right? So it's good that we're like skipping 94 or 80 because that one's a diagonal, but we're missing two values there, and that's an issue.
Yeah. Can you scroll up?
Yes.
All right. So what you're doing line and lines, splitting.
Yep.
Parsing a coordinate. I just did a regex for parsing it.
Oh, nice. Rust doesn't have regular expressions like built in, so.
Oh, yeah, I pulled in a dependency. If x1 equals x2, then for y and y1 to y2, and is that dot dot equals a inclusive range?
Exactly. Yeah.
Yeah. If so, a problem which I had is you can't just do the counter thing actually, because you overcount if there's more than two intersections. You need to have two hash sets, one for the ones that you have seen once, and then instead of the counter you have an additional hash set that you push everything that you've already seen into, and then you just count that hash set at the end.
Isn't that like a thing for the second part though? Like the first part, you kind of like,
because you could still have overlap. You could still have like three points.
Wait.
Which overlap? Like you could have.
Oh, like that. Yeah. Hold on. Because I thought like in my mind, I was like horizontals and verticals are the only ones that can overlap, which means you have like a perfect little cross and nothing else can overlap. But you are entirely right saying that, well, you can have multiple like horizontals or verticals overlapping. At that point,
Yep.
Yeah, exactly. So we're like totally overcounting, but also we're not inserting like correctly. So there's two issues. Yeah, you're right. Lemma intersects equals. We can just copy that. Chord equals x1 or x comma y1. Chord. And then here we can say intersects dot insert chord.
Yeah.
And
same with the other one.
Can we do the fancy extract to variable? No, not yet. Extract to variable. Yes.
Nice.
Chord. It might not be Visual Studio, but it is Visual Studio Code. It codes some stuff. Yes, and then here we say intersects.len.
Yeah.
I think.
Yep.
All right, let's run this again. I think it's like still broken because our insertions were off. Left, 11, right, 5. Maybe we're like misparsing. Maybe that's what's going on.
Yeah. Have you tried just like on every line, just output what your parser thinks the line is?
Oh, you mean like... Wait, hold on. What do you mean?
I just mean like, on each line, do the parsing and then print out your your x1, y1, x2, y2.
X1, Y1, X2, Y2. Oh, Y2. All right, let's do that. Running once again. 095980089434. That looks exactly correct.
Mhm.
Yes. And so
So what do you think is going wrong? You're saying that something's going wrong. What's going wrong?
So if we print our coordinates
Yeah.
here, then we are seeing that we are not inserting all coordinates, that we are like straight skipping things. So like our equals checks are off somewhere, right? So 0919, that's good. But then these 94,34 should be getting like inserted somewhere.
Oh, it's because you're scroll up. It's because you're not handling the case where the line is going from right to left or down to up.
Oh, hold on. Wait. Rust doesn't do like negative ranges? Hold on.
What I did was just go from the minimum to the max.
Oh yeah, that makes sense. I think you're probably like entirely right. Where did my terminal go? All right. Well, you're probably entirely right. Do we see like true printed and stuff? True equals true. True equals true. True equals true. Yeah. You're entirely right. That's what's happening. Like our Boolean checks are correct, but how do I do like a min-max one? That's annoying. How did you do this in C++? Is there like a convenient?
I just looped from min of the y's to max of the y's and min of the x's to max of the x's.
Okay, well, I guess that works. Y dot min y2 dot max. Like that?
Yeah.
Okay.
Apart from you did y1 dot max y1.
I did, didn't I? Okay. X. What? X. Ugh. All right. Let's give this a loop.
Now you did x1 max x1 as well.
Oh no. Can't we just have a silver bullet language that guards from every single logic error ever? That's what I want.
Then you wouldn't need programmers.
Exactly. Would mean I'd get to have vacation, right?
Yeah.
Okay, so well we know that works. 29394959 344 5474. If items insert chord.
So what does intersex end up as?
Yeah, that's a good question.
Intersex set.
Do we need those debugs? Sure. Okay, let's run it again. Zero 9293449. Is that correct? How do I check this? So we're saying if we have seen an item already, then we insert.
Is that what
thing in intersections?
When you do a hash set dot insert, does that return whether it was already in the set or not?
Yes. I mean, it should. Hash set insert adds value to your set. Oh wait, hold on. If the set did not have this value present, true is returned. Oh yeah, I'm doing it exactly the wrong way around. Thank you for making me check that. Okay, running once more. Boom. Okay, that was it. Let's remove the debugs. Remove debug. Remove debug. Remove debug. And then where's the final one? There. Running once again. Okay, that straight worked. Did we have our 5 input text? Not yet. Let's get the puzzle input. Oh, we need more than a U8, don't we?
Yeah, you do.
U size. Sure. And then let's verify this works. Okay, that did. I don't have a terminal. Run, cargo run. Day 5, output 1. Day 5, output 2. Okay, so 5124.
5124?
Yes. Is that what you had?
No, because our inputs are different. But
Oh. Hey, that's
Yay.
right. Yay, amazing.
Good job, good job.
Cool, part 2, diagonals. Unfortunately, only horizontal and vertical lines don't give you a full picture. You also need diagonals because of the limits of yada yada yada. 1 1, 3 3, 1 1 2 2 3 3. Okay.
So it's exactly what we thought it was. It's just exactly the same, but now you also check for the diagonals and handle that properly.
We need a third case.
Yeah.
That makes sense. Let's just make this an else if. And the final case is...
Yeah, that's what I did.
Yeah, exactly. Oh, that's nice of them. All right. How did you do the stepping logic?
So I just calculated the. I assumed we always go from x1 y1 to x2 y2. So I calculated the x direction by checking if x1 is less than x2, and then so if x1 is less than x2, then we're going to be stepping positively, and otherwise we're going to be stepping negatively. So I just stored the x direction as 1 or -1, and the y direction as 1 or -1, and then I just looped from 0 up until the distance from x1 to x2, and just did the x1 plus distance multiplied by the direction. And
in C++, can you get a loop over tuples? Does that just auto increment step?
What do you mean? Sorry.
So one fun thing that I was trying to do is I was attempting to do four chords in x1 comma y1 dot y x2 y2 like that, and give me a tuple, but it doesn't do that in Rust.
Yeah.
The C++ has that?
No, not directly. You have to write some kind of range adapter for that.
No, that makes sense. Yeah, same here. All right. So step 1 is figure out the direction. So if I guess unlike the first two is we know that we just need to check either x1 or the x coordinates or y coordinates, because it will always be diagonal. So if y is bigger, then x will be bigger as well, I believe, right? Something like that.
No, because it could be going from bottom left to top right, or from bottom right to top left. It could go in any 4 directions. The line, the distance from x to x will always be the same as the distance from y to y, which is something that you can use. But,
x, y to y. Oh, true.
Because it will always be exact diagonal line. There's not going to be like a line which goes down 1 but across 4 or anything like that.
Yes. Brain is soup. How do we do this?
So the X direction is just going to be 1 if is there a ternary operator in Rust? I can't remember.
No, but I can write it out.
Then you just do if x1 is less than x2, then 1, otherwise 0. Otherwise -1.
Oh.
Then exactly the same for y.
Okay.
Yeah. And then you're just going to loop from 0 to the absolute value of x2 minus x1.
X2 minus x1. Wait, what?
Looping from 0 up until the absolute value of x2 minus x1.
X2 minus x1. You've been parsing these to I sizes? You have like signs on them, don't you? No.
Yeah.
You do. Oh yeah.
You need the ABS of x2 minus x1 because you don't know which one's bigger.
.abs. What does that do? I just know abs like anatomy.
Absolute value.
Yes. Oh, interesting. I thought because we were like dealing with I sizes. Are you using floats? Hold on.
No. You just need like if it's negative, you need it to be positive. That's it.
Oh, okay. In math, it's x2 minus x1, so it's always positive.
But you don't know whether it's a left to right or right to left.
Oh,
yeah.
I didn't know.
You have ABS on integers as well, so that should.
That's cool. No method named. ABS for type, U size. Okay, as I size. I've never used this. Thanks for like dictating, by the way. I really appreciate that. Step in. Okay, next.
Yeah, so then you're just going to go from, you're going to insert into items. Well, you're going to do the same thing as the other ones, but your coordinate is going to be x1 plus distance plus step times x direction.
And we don't need that.
Yep.
We can rename this to distance chord.
Yeah, x1 plus distance times x direction. You need the y coordinate as well.
Okay, we're having some issues there, and then we do this for y once more.
You only have the x coordinate in chord.
Yes.
No. Your coordinate isn't a coordinate. It only has the x.
Oh,
you need the y.
And then I see. Y1 plus distance times y direction. Okay. We are, and then we can say as U size. As U size? No, can I multiply I size by U size? That's I size. Let y direction is a I size. Distance I size. That's a U size. As I size. Love this. Very happy. Okay, that needs to go. That needs to go. Let chord equals chord dot 0 as U size. Chord dot 1 as U size.
Many casts.
Yes. Good times.
That looks good
times.
though. I think that should probably work.
Oh, hold on. And our total of 12 points. So our second test can become that, and then we can run that and see what happens. Hey, it worked. Wow.
Yay.
Yay. Cargo bin. Advent of code. 19748. Submit.
Mine
right
was
answer.
quite a bit higher, so too low.
Yeah.
Go back to your code.
Okay. Here's our coordinate stuff.
You did exactly the same mistake that I did. Your loop is off by 1. You need the inclusive.
Oh, that equals.
Yeah. It's exactly what I did as well.
Amazing. Okay, running it again. Oh, it's not that much higher.
No, that's fine.
That's
Mine was the same. It's just a tiny bit higher, but that's all I needed.
I think it's like, is it like even lower?
No, it's not. It's a little higher.
A little bit. Submit. Hey, that was the right one. Sweet. Yay. Thanks so much. What's the time? We started about 10 minutes later. Hour and 7 minutes. That's pretty good.
Yeah. Kill your screen share so that you show up on my stream.
Yes. Yay.
Cool. All right. Yeah. Got it all done. That's fine.
Thanks so much, everyone.
Yeah, thanks for joining. We'll see you tomorrow.
See you tomorrow.
Have a good day.